Young biologists, this is our first video for the year in AP Bio. The purpose of these videos is to provide the foundational information for topics and give you a reference that you can always go back to. Then, in class, we can practice, go deeper into certain topics, and introduce more advanced concepts. Let's get on with it. This is video 1.1 on organizing experiments. This video will cover these 4 course goals. Pause for a closer look. One type of variable that every experiment has is the independent variable. Notice that I replaced the I in independent variable with the number 1. That's because this change can help with the definition. The independent variable is the one condition changed between the control group and experimental group in an experiment while you're setting it up. In other words, the IV is the one condition being tested. In the example shown here, setup A, B, and C all have plants in pots. The scientist is testing what liquid makes the plant grow tallest. In this experiment, the one condition changing between the groups is the type of liquid given to the plants, water versus juice versus cola. Next is the dependent variable. I've underlined the letter D to remind us of the definition. The dependent variable is the data collected in an experiment. In other words, it's what's being observed or measured once the experiment gets started. Data can be qualitative, characterized by words, or quantitative, number data. Usually, quantitative data is preferred by scientists over qualitative. When you think of the DV, it's important to be specific. In this example, the dependent variable is plant height. It's less helpful to say plant size because that can mean many things. So to be specific, think about the measuring tool and units needed. In this case, a ruler could be used to measure height, probably in centimeters. Moving right along, we've got constants, and I've underlined the S in constants to help you think of the S as standing for same. Constants are experiment conditions that are carefully kept the same between the different setups. Constants are super important because constants build confidence that any change in the dependent variable is caused by the independent variable only. If there are a bunch of changes between the different setups, you couldn't tell which change caused an increase or decrease in the dependent variable. In AP Bio, it's important to identify at least 3 constants in an experiment. Now, in the example, maybe the scientist used the same size pot with the same volume of soil. They used the same plant species, and hopefully the plants received the same volume of liquid and were watered at the same time of the day. Finally, we have the control group. The control group is used as a comparison in an experiment. One example of a control group is a group that doesn't receive a treatment or independent variable. For example, to test a medicine, you give the medicine to some people, then compare it to a control group that doesn't get the medicine or maybe gets a placebo. Other times, a control group may be a set of normal conditions, and then the experimental group gets the changes in the independent variable. In the example, the control group is the plant receiving water right here. Giving a plant water is normal conditions, and then the plants getting cola or juice are the experimental groups. There are a couple more things we need to be sure we're on the same page with: writing scientific questions, hypotheses, and null hypotheses. Sometimes these formats can be a little bit awkward, but that's okay. Scientists like to be organized and stick to a format, sometimes at the expense of sounding really smooth. A simple way to write a scientific question is, what is the effect of blank on blank, where the first blank is the independent variable and the second is the dependent variable. A hypothesis and null hypothesis is pretty similar. In AP Bio, you can write a hypothesis or null hypothesis as if-then statements, where the if is the independent variable coming after that, and the then has the dependent variable. Both the hypothesis and null hypothesis should be testable predictions. A hypothesis is what the scientist thinks is most likely to happen, and a null hypothesis is a prediction of no change between the control and experimental groups. Now, it might be confusing right now, but the purpose of a null hypothesis will be more clear as we move through the course. In our plant example, a hypothesis could be, if I give the plants different liquids, then juice will make the plant grow the tallest. And a null hypothesis then would be, if I give plants water, juice, or cola, then there will be no difference in height between the plants. So let's recap. Experimental design is universal worldwide among scientists so that scientists can efficiently understand each other's research. This means that experiments should have clear variables and constants. Making sure an experiment has a control group ensures that any changes in dV are due to the IV independent variable being tested and nothing else. Finally, having a uniform format to express scientific questions and hypotheses creates an easy access points for even the most complex experiments.